Moving on to 2.2. Similar triangles. Everybody say similar. What does the word similar mean? Hakeem. Almost alike. Michaela, what were you going to say? They have things in common. Good. What else? Pretty much covers it, right? If someone, has anyone here have siblings? Yeah? Yeah, most of us do. Has anyone in your family, or maybe even someone not in your family, told you, oh, you and your sibling look so much alike. You look so similar. Right? Does that mean you look like identical twins? No. It means you have some features that are the same. Yes, there are some identical twins. But if you say, oh, you guys look very similar, that doesn't mean you look exactly alike. It means you look kind of alike. You guys get what I'm saying? Yes or no? Okay. So triangles that are similar. All right, we're coming back together. Okay, just because you're all the way back there. Similar triangles are the same thing. They don't look exactly alike, but there are some features of a couple triangles that we're going to see that they have in common. Things that are similar to one another. So if I have a figure, in this case a triangle, that is similar, it means I have the same shape, but different sizes. Kind of like a dilation. So yesterday all we were doing essentially was creating similar triangles. They have the shape in common, but the size is different. Which is pretty common when you have a younger sibling or an older sibling that you look kind of like. One of you is going to be a different size, right? Taller, older. But overall, you're shaped the same. Oh, you both have the same eyes. You have the same nose. You have the same lips, whatever the case may be, right? But you're different sizes. Okay, now if you have identical twins, that would be more congruent than similar. They're the same shape, same size, same features, same everything, right? But similar, a little bit different. I mentioned this analogy yesterday. If I have the same exact t-shirt in a size small and a size large, right? Notice they both have short sleeves. They both have a regular hem in the neck. And this one says big guy, this one says little guy. So they are similar figures. They're not congruent because they're different size shirts, but they're the same shirt. You guys get me on that? Yeah? Okay. So specifically talking about triangles, we know that triangles are similar. Did you get all done? Okay, you can head back. We know that two triangles are similar if their corresponding angles are congruent. We'll talk about what that means later. We know what congruent means, equal. So their angles have to be equal. But their side lengths, we know they're different sizes. My side lengths are not going to be congruent. My side lengths are going to be what we call proportional. Everybody say proportional real quick. Have we heard this term before? Yes, we have. It was the very first thing we learned. If someone were to say, oh, you're very, proportional, right? Or let's do the opposite. Let's say you're unproportional. You got super long legs, super short arms, right? That's not proportional. But if you have, equally sized arms and legs comparatively to each other, that's what would be considered proportional, right? If you say, oh, your shirt is not proportional, I'm wearing a 5XL tee, right? It's not proportional to my body. It's too big. So proportional is kind of like a relationship between sizes. Yeah, go ahead. All right. And then what does congruent mean again? You guys remember what congruent means? No? The same. Same shape, same size. Okay? So we're going to talk about these couple ideas here a lot. The first is corresponding angles. Corresponding literally just means same spot. corresponding just means the same spot. So if you think about your desk groups, every desk group has someone in seat A, right? Ayana's seat A, Ramesa, Haley, Xavier, Hunter, Javen, Z, Billy, and Vanessa are all seat A. In relation to all the groups, they're all in a corresponding spot. They're all in the front left corner of their group. From my perspective, from your perspective, the front right corner. But they're all in the same spot. Same thing with everyone in seat D, like Amari, Caleb, Lola, Kyla, Johnny. The middle group a little bit off because there's 5 of you, but Key, Taya, yep. You're all in this corresponding part of your group. So it should mean same spot. Corresponding sides are the same thing. Okay? Corresponding sides are in the same spot as well. Now, with similar triangles, the important distinction between these two is that corresponding angles are going to be congruent, right? But corresponding sides are going to be proportional. Okay? Everybody with me so far? Okay, thank you. So I've got 2 triangles here. Are these 2 triangles the same size? Look at them. Are they the same size? No. One is much bigger than the other. Do they look shaped the same though? Yeah, like we said yesterday. They're the same species of triangle, but they are different sizes. Here I've got triangle ABC. Here I've got triangle XYZ. Now we notice a couple different things going on inside the triangle here. Do you recognize any of these symbols going on inside the triangle? Yeah, what do you recognize? The right angle. Which one's the right angle, Amari? The little box, this little square. How many degrees is that angle going to be? 90. It's 90 in this triangle. It's 90 in that triangle. They're both in the bottom left corner. You guys see that? Bottom left corner. So these 2 angles here, these 2 little right angles, are corresponding with each other. Angle B and angle Y. So right here in the middle, we could tell just by looking at these triangles that angle B and angle Y are congruent. What does congruent mean again? The same or equal. And obviously all right angles are going to be congruent to each other because they're all 90 degrees. They're the same amount. Right? Angle A is down here, this little right side point of the triangle. What would the corresponding angle be in my big one compared to triangle A? Who's in the same spot as who's in the same spot as angle A in this big triangle? Angle X. You're in the same spot. That bottom right kind of thin point of the triangle, angle A is going to be congruent to angle X. You guys see what I mean by that?
Yeah.
When I say they're in the same spot?
Yeah.
Who's in the same spot as angle C? Z. So I know that angle C is congruent to angle Z. Figuring out the angles is the easy part. The trickier part is figuring out the sides. We can tell that these 2 are similar. If I want to identify the corresponding sides, I've got to look at what sides I've got. So this first one says side length BA. This little squiggly line just means proportional, not equal, but proportional. BA. Let's do it in this color. Here's side length BA down here. When I look at my big triangle, what side length is in the same spot as BA over here? YX. Good. YX. What spot are those two sides in?
Bottom.
They're on the bottom. That's right. Both on the bottom. They both stretch from this purple right angle to this pink pointy angle. B to A and Y to X. I don't want to call this segment XY because then I'd be flipping it. I want to call it YX. Okay? Let's look at AC. Here's AC.
I got it.
Johnny, help me out. What's the corresponding side to AC?
XZ.
XZ. Great job. Could he have also said ZX and been correct? No, we just said. You've got to go in the same order. So from the pink point to the teal top, pink point to the teal top. AC is proportional to XZ. And finally, I've got CB. I've only got one side length left, but I could still name it wrong. Who can I say is proportional to CB in my big triangle? Z, Y. That's right. I'm going from my teal tip, or my teal top, down to that purple right angle. That's my left side of these triangles. Okay? These triangles are similar. They're shaped the same, but they are different sizes. That is similar. So what we're going to do with this is we can set up a proportion to solve for a missing side length. We'll see an example of that in the next one. Okay. But if I were to say that side BA, which is this guy, over side YX, so it's my small base of the triangle over my big base of the triangle. There's a lot of talking still back there for some reason. I don't know why. If I was going to set up a fraction with one of these other pairs that matches the way this fraction is written, let's take this red pair right here, AC and XY. Which of these is going to go on the top of my fraction? AC or XY? AC or XY? AC. And X, oops, that's not an X. X, that's not a Z. XZ goes on the bottom. This may be a little bit confusing. It'll make more sense once we see the actual work. We could say that proportion is also equal to CB over ZY. I know it probably sounds like I'm speaking a different language right now, because I kind of am. Don't worry. The actual work is much easier. This is just kind of conceptual understanding what we're talking about. All right? Go ahead and flip to the second page for me. This is the actual work. This is where our highlighters are going to come in play. We're given the information that ABC and DEF are similar. They have the same shape, right? They look like cousins, which means they also have the same angle measures. Question on that?
I don't have the second page.
Okay. Does anybody else not have the second page?
Okay.
see a couple numbers there on my triangles. Do I know any of the side lengths of triangle ABC? I see a 6 and I see a 7. Right? I know. And I made this paper last year too, which is sad. So I've got side. What can I call the side length that's 7 units long? What do I call that? It's 2 letters. What letter is this?
AC.
AC. What corresponding side do I have on my big triangle? What's the same in the same spot as AC is what?
DF.
DF. You guys see how they're in the same spot? They're both on the bottom. What other side length do we know in my small triangle?
BC.
BC. What's the corresponding side in my big triangle?
EF.
EF. How long is side DF in pink?
14.
14 units. How long is EF in yellow? EF is X units long. Do we know how long it is if it says it's X units long? No. That's going to be what we try and find. It can't be 0 because I can see it's got some length to it, right? So what we need to do is set up a proportion. Another word for proportion is a fraction. It's like a fraction equation. I'm going to set up 2 fractions. And in my fractions are going to be corresponding sides. So I'm going to put my small pink side over my large pink side. What's my small pink side's length? 7. What's my large pink side's length? 14. Everyone see how I set that first one up?
Yeah.
Okay. Then I'm going to set up another fraction with my yellow sides. BC. How long is BC?
6.
6. And how long is EF? X. There's a bunch of different ways to mess up this proportion writing process. So hopefully this color coordination kind of helps as you're working through our worksheet today. I'm going to pick out how I'm supposed to be setting this up, what it should be looking like. All right? Do you guys remember how to cross multiply?
Yeah.
Okay. If I cross multiply, I'm going to make a little kind of bubble X with my terms here. On one side, I'm going to have 7 times X equals, on the other side, I'm going to have 14 times 6. You guys remember how we cross multiply like that?
Yeah.
It's pretty straightforward, right? Okay, cool. Well, what is 7 times X? 7X. 7 times X is 7X. And what's 14 times 6? 84. Great job. Quick math there. Almost done, Joseph. So I got 7x equals 84. Does anyone remember what I can do on both sides to get this x all by itself? You said what? Divide. What am I going to divide both sides by? 7. The reason I do that is because these 7s now are going to cross out, and I'm left with x equals, what's 84 divided by 7? 12. Here's my answer. This yellow side here is 12. It is a lot of math. But how we can check our work sometimes is a lot easier. Take a look. We just talked about dilations yesterday. If I start with this smaller triangle and work my way up to this bigger one side length is 7, the other side length is 14. How much bigger did my triangle get? 2 times as big. It was 7 feet, now it's 14 feet. I got twice as big. So if this side is 6 and 6 gets twice as big, what should the other side be? 12. And that's exactly what we got. Sometimes it won't be that easy to just look at and see. So we're going to have to do this cross multiplying. Are there any questions about how we set that up and got through it? Okay. Here's what I want you to do. Give these 2 problems a try. It's okay if you get them wrong. Please do this in pencil because some of us, half of us, will get it wrong. And that's why we have it in the notes so we can learn from that mistake. Okay, give it a shot. I'll be right there. Joseph, go real quick.
This is scaring me.
It's scaring you.
Yeah, so there's no letters on the first 2.
The letters don't matter because we're setting up a proportion of just the side length. So highlight your sides. Let's do that. Right? My big side of 9 and my big side of x. My smaller side of 5 and my smaller side of 15. See if that helps get you jump started. What's up? A calculator. Yeah, give me 1 second.
Can I have one?
Okay, what's 135 divided by 5?
I want to see the cross multiplication. It's like 2 steps. It's not bad. Make sure you're awake. Uh-oh. So, when I have the corresponding sides, I need each of the letters to also be in corresponding spots. So like A should be corresponding to X, which we know it is. And C should be corresponding to Z, which we know it is. B should be with Y. Boom. C should be with Z. The reason, you said no, please. We're going to get more, we're going to talk more about triangles, and there's 3 letters. It'll be more important. Don't worry, we're going next week. But try that one.
Are we doing both? We're jumping.
Even worse.
What's 36 times 6?
I think we're
Yeah, 36.
I can't see it.
Well, that's a lot.
What's that divided by 36?
9 over X, 5 over 15. 6. Good job. Try the next one. Try the next one.
Oh, Brad, I'm going.
What's up?
Guys, it's looking
Once you get an answer for X, see if it makes sense that that side length would go with that triangle. If I get something like X equals 2, it's probably not going to make sense. If this side is 15, I can clearly see X has got to be bigger than 9, right? So if I get something smaller, I know something definitely went wrong in my setup. What's up?
Is this right? Look in our direction.
9 over X equals 5 over 15. 5X equals 135. Yep, that looks fun so far.
Wait, but I'm supposed to put 5 as this denominator, right?
Yeah. Now you just divide 135 by 5.
Okay, wait, sorry, can you get this out of mine? So, remember, if I have an X, right?
Yep.
Then I would automatically make it my denominator?
Yep, because you want to cross them out.
Okay. Oh, okay, I got it.
Yep. Great job.
What else do I do? I don't know. How did I get 12? How did we get 12? Did we get 5?
6. Oh, no, you're right.
Do you know if we divided when we did the work? When we just did it?
36.
I know, but
Someone's in the bathroom. This is easier than I thought it would be.
Wait, so I do this or do I divide?
So the 5s on the right cancel out. That's why we did it. Now you divide 135 by 5.
Okay.
And that gives you X. So yellow over yellow equals pink over pink.
Oh, period, I did it.
9 over X equals 5 over 15. That's how you should set it up. Just like we did over here, we did pink over pink equals yellow over yellow. So 5 over 15 equals 9 over X. Set that up.
Yes, high five.
Good. When I cross multiply, this is 5 times X, which should be 5X. And 9 times 15, which should be 15 times. So you mix up. Yes, except your division is off. Nice. Yes, you gotta show a little more work than that, but you're right. Good job. Good job. Yeah. Good job. So X equals 27. Yeah. Yeah. What's that?
I got 9.
Equals 135. Yeah. Well, when you cross multiply like that, right, you get 135 on one side. What do you get on the other side? What did we get up here on the other side? We got 84 on one side and we got 7X on the other. So what do you have on the other side in that problem? Yeah. Yes? Yeah. 9X. So instead of dividing both sides by 7, you're going to divide both sides by... Yeah. That's it. Yeah, good job. Alright, looks like most of us get it. Yes. So, with the highlighting, this is red. You have the first yellow side over the second yellow side equals the first pink side over the second pink side. That's exactly what you did. Cross multiply, you got 135 equals 5X divided by 5. You got 27. Now do the same thing over here. Big pink side over small pink side equals big yellow side over small yellow side. Cross multiply, divide by whatever's in front of X, and you get your answer. Plus you can kind of see, look, 36 and 36. This side's going to be 6 and... Yeah, but we just got to do the work for it. All right. Make sure you get the sandwiches. Yeah, go ahead. Don't worry about it. It's all right.
Amar, that's disgusting. You literally was like this.
All right. Like I said, most of us got this right. Let's take a look to make sure. What's the first fraction? Okay, guys, we're coming back together now. That means please stop talking.
5 or 15.
First is yellow side.
9 over X.
Yeah, hold on. I'm still waiting for people in the back. Once again, somehow.
A 1
They're being selfish and rude and not listening when we're talking. Okay. Small yellow side over big yellow side is going to look like what? Small yellow side over big yellow side?
9 over x.
9 over x. I'm going to set that equal to small pink side over big pink side, which is
5 over 15.
5 over 15. When I cross multiply, I'm going to scoop up x times 5. That's going to be 5x. Right?
Mm-hmm.
And then 15 times 9. What's 15 times 9?
135.
135. Everybody cool with that?
Yep.
What do I have to do on both sides to get x all by itself?
Divided by 5.
Phaedra?
Yeah.
Divided by what? 5. Whatever's in front of x, that's what I'm dividing by, so I can cross these out and get my x all by itself. I'm sure we all know this off the top of our heads. Let's see. How many times does 5 go into 135?
27.
27 times. Give me a thumbs up. You got x equals 27. Very nice. Over here, same thing. I got my yellow side on the bottom, yellow side on the bottom, pink side on the right, pink side on the right. Okay? So, big pink side over small pink side. What's that going to look like? Big pink side over small pink side.
36 over x.
Thank you. And you may have set this up slightly different. Just wait and see how it pays off. What about big yellow side over small yellow side?
36 over 6.
36 over 6. Now we can kind of already tell just by looking at this what my x is going to be. 36 over what equals 36 over 6? It's pretty obvious, right? But let's do what we're supposed to do. Let's cross multiply. I got x times 36, which is 36x. I got 36 times 6, which is 216. Right?
Yeah.
Hakeem, what am I going to divide both sides by? You got this. What do I divide both sides by to get x all by itself? You got it. Yeah. What'd you say? Yeah, 36. My 36's go away. How many times would 36 go into 216?
6 times.
6 times.
Yes.
6 times. There we go. That's not a whole lot of work to show. Good morning, sir. It's not a whole lot of work. Like I said, some of them you can look and see the pattern and figure it out. Thank you, sir. But we still got to show the work. We got to cross multiply because it's not always going to be that easy. Alrighty? We got a good 20 minutes.